Hello everyone. Let's go over chapter 4 review from our textbook. As usual, you will see I skipped some questions because there are too much computation and a big use of calculator thingy. While the idea is simple, so I will just skip to the parts that I think we really need. Number 3, and I will circle the type of question that I don't think I will ask in my class, but some teachers would like may ask those kind of questions. Okay, number 3, uh, evaluate by interpreting it in terms of area. So this guy is equal to, maybe I rewrite it again, integral from 0 to 1 of x plus square root of 1 minus x squared dx. I will split that into two integrals, the sum of two integrals, and then interpret them geometrically. So the first one is the integral from 0 to 1 of y equals to x. Well, if we integrate that, you see this is integrable, right? This is 1/2 x squared from 0 to 1. You will see that's 1/2, which is the area of this triangle here, right? The base is 1, height is 1, therefore the area is 1/2. Now, the thing here is, then I don't know what's that. Let's see further. What is that? That's 1 minus x squared. That's a semicircle from -1 to 1, right? Oh, hold on. From 0 to 1 only. So from 0 to 1 only. So while we don't know how to compute that integral yet, but because we see what it looks like and we can compute that this is a quarter of area of a circle with radius 1, right? So this is plus pi over 4, or we can simplify that to be 2 plus pi over 4. Okay, let me move this a bit to the left. Therefore, I can move this up and save some space. Number 4, express this limit of sum of sine xi delta x. Limit sum and goes to infinity of the sum I from 1 to n of sine xi delta x, definite integral from 0 to pi. Okay, so this is basically integral from 0 to pi because they tell us so, right? And of the function sine x dx. Okay, maybe I say it this way. This guy here give us the integral. The fact that tell us from 0 to pi give us the limit of integration. Okay, now the delta x then becomes dx. Okay, so the function is sine xi that we keep. Okay, now to integrate it, I think you can just integrate it yourself, right? That's equals to 2. I hope so. I hope you know how to integrate that. Okay, let's see next. Okay, integral from 0 to 6 is 10. Integral from 0 to 4 is 7. Find the integral from 4 to 6. So from 0 to 6, the area is 10. But from 0 to 4, the area is 7. Oh, okay, so we need to find the area from 4 to 6, huh? That should be 3, is it right? But let's write it properly. Okay, let's write it properly. Integral from 0 to 6 of fx dx, that is equals to integral from 0 to 4 plus the integral from 4 to 6. Okay, now we know that integral from 0 to 6 is 10, integral from 0 to 4 is 7, so integral from 4 to 6, you can subtract those two numbers. Thomas, will you ask this kind of question? Even if I do, I think this is quite easy. Okay, even if I do that, I think this question is quite easy. Next one, number 8. Evaluate this. Oh, you see, that's the derivative of something. Integral 0 to pi over 2, the derivative of a sine x over 2 cosine x over 3 dx. But we will integrate that again, right? So suppose this is our f, right? Suppose that's our f. The derivative of f respect to x, let's say this will give us the function then. Okay? But then when we integrate that again, that will give us the f back. Is it right? Okay? Does it make sense? Do you see that when we integrate that? So I can now say that this guy is equal to basically sine x over 2 cosine x over 3 from 0 to pi over 2. Okay? That's one way to do it. That's one way to see it. Another way to see that happens to be that the dx cancels. So we have integral from a to b of d blah. That's equals to blah from a to b. Right? Do you see that? Okay, that's another way to look at that. Okay, well, because derivative and integral is antiderivative. In other words, integral as a process undoes derivative. Okay, so this will be sine pi over 4 cosine pi over 6 minus sine 0 cosine 0, which is 0. So this is radical 2 over 2 times radical 3 over 2. That's radical 6 over 4. Okay, now part B. How about the derivative of that integral? This one we need to be a bit careful. The derivative of this integral from 0 to pi over 2 of sine x over 2 cosine x over 2 dx. This one we need to be careful. Why? Because if the integral of this exists, let's call that capital F, then this will be f at pi over 2, which is a number, minus f at 0, which also a number. Now the derivative of a number is 0. Okay? In other words, you see that this is a definite integral. A definite integral, when we compute that, it will give us a number. Right? It will give us a number. Now the derivative of a number with respect to any variable, it will be 0. Okay? Now it's different from what we have in part C. In part C, okay, this is the derivative of f at pi over 2 minus f at x. Right? Okay, now the first term, the derivative of the first term will be 0, minus the derivative of second term will be that function itself at x. which, if you think about it, that's basically fundamental theorem of calculus, the first part. Application of fundamental theorem of calculus, the first part. Okay. Number 9, graph F consists of 3 line segments shown, where if gx, so this is the graph of F, huh? Now, what is gx? Gx is defined to be integral from 0 to x of ft dt. Okay. So what is G4? G4 is integral from 0 to 4 of ft dt. That's the area from 0 to 4. The area from 0 to 1 is -1. From 1 to 2 is +1, right? I mean, maybe I enlarge this a little bit, right? The base is 1, the height is 2. The base is 1, the height is 2. Okay? So that will be -1, this is from 0 to 1, plus from 1 to 2 is 1, from 2 to 3 is 2, and then from 3 to 4 is another 1. So the area is 3. Okay, now what about the G prime 4? G prime 4 is the derivative of respect to G, the respect to X of that integral. The notation seems to be complicated, I know. This is T. Observe at 4. Okay, but the derivative of such integral as a function is the ft itself. Okay, now f4 equals to 1, 2, 3. F4 equals to 0. Yeah. Okay, that's f4 equals to 0. That's for number 9. So question number 9 is actually not too hard if you understand what we need to do. Okay, number 11 to 32, I will do all the problems here because these are the cream of the crop. Okay, you need to know all of this. You need to know all of this. Okay, let me enlarge a little bit so that I can see it better. Yeah, so number 11, integral -1 to 0 of x squared plus 5x dx. You don't need to do it as fast as I am, but you still need to do it fast, okay? With some practice, you will get used to it. And it also prepares you for your Calc 2. At Calc 2, your instructor will assume you know this thing already. Not only you know this thing already, you know this thing very well. Okay, this is 1/3 x cubed plus 5/2 x squared from -1 to 0. So at 0, there will be 0. At -1, there will be -1/3 plus 5/2, which is 1/3 minus 5/2, 2/15. That's -13 over 6. That's for number 11. Number 12, integral from 0 to t of x to the 4th minus 8x plus 7 dx. That is equal to 1/5 x to the 5th minus 4x squared plus 7x from 0 to t. Oh, just replace that x by t and 0, right? When I replace by t, that will be 1/5 t to the 5th minus 4t squared plus 7t. But at 0, it will be 0, so I just leave it like this. Number 13, integral from 0 to 1. This is x minus 1 over 10 x to the 10th from 0 to 1. At 1, that is just the coefficients, right? Because it's polynomial. At 0, it's just 0. So this will give me 9 over 10. Number 14, however, oops, the 9 is outside. So I need to do substitution. U equals to 1 minus x. So du is negative dx How about the limit of integration? U at 0 is 1, U at 1 is 0. So now the integration becomes integral from 1 to 0, U to the ninth negative du. Okay, which is equal to, if I reverse the limits of integration, the interval I reverse, it will absorb the negative. It becomes integral from 0 to 1, U to the ninth du, which is 1/10 U to the 10th from 0 to 1, which is just 1/10. You may think I'm doing it too fast, but that's actually the speed I expect from you. Okay, but at the same time, in your test, during your test, just do it at a regular pace, the pace that you feel confident with. Okay, you don't need to rush it though. You need to do it right first before you do it fast. Okay, number 15. Integral from 1 to 9 of square root of u minus 2u squared over u du. That's integral from 1 to 9 of u to the negative 1/2 minus 2u du. This is 2u to the 1/2 minus u squared from 1 to 9. At 9, this will be 2 times 3 minus 3 squared. Minus at 1, that will be just the coefficients. So 6 minus 9, negative 3 minus 1, that's negative 4. Okay, number 16. I think I would just do it down here. Number 16, integral from 0 to 1 of u to the 1/4 plus 1 squared du. I don't think I can do substitution here. So let me FOIL that then. So integral from 0 to 1 of u to the 1/2 plus 2u to the 1/4 plus 1 du. And then when I integrate, I get 2 over 3u to the 3/2 plus 2 times 4 over 5 u to the 5/4 plus u. From 0 to 1, it's polynomial thingy, right? Not exactly polynomial, but we can call that polynomial, right? So at 0, it will be 0 later on. At 1, that will be just the coefficient. Okay, so 10 plus 24, 34. Let me write it down. 10 plus 24 plus 15 over 15. What is that? 49 over 15. Number 17, integral from 0 to 1 of y squared plus 1 to the 5th dy. Oh, I have y squared plus 1 under that exponent 5. I need to use u substitution. U equals to y squared plus 1, so du equals to 2y dy. So later on, our y dy, this guy here, y dy will be equals to du over 2. Okay, u at 0 is 1, u at 1 is 2. Is it right? So now the integral becomes, let me partition this. The integral becomes integral from 1 to 2 of u to the 5th, y dy becomes du over 2. So this is 1/2, 1/6, u to the 6th from 1 to 2. Okay, this is 1 over 12, 2 to the 6 minus 1 to the 6. What is that? 63 reduced by 3, that will be 31 over 4. Okay, I think I can do the same thing with similar to number 18. Yeah, I have space on the right. Let me move it to the, still work on the right. Number 18, integral from 0 to 2 y squared square root of 1 plus y cubed dy. Inside the radical, it's not integrable, so I substitute. So u equals to 1 plus y cubed. Du is 3y squared dy. So our y squared dy later on, because I see that, right? This is our y squared times dy. Later on will be replaced by du over 3. As for the limit of integrations, at 0 that is 1, and at 2 it will be 9, right? The integral from 1 to 9 of u to the 1/2 du over 3. That's 1/3 times 2/3 u to the power of 3/2 from 1 to 9. 2 over 9. Square root of 9 is 3, cube is 27. I'm sorry. It must be a blow to your ears too. I'm sorry. And 9 to the 3/2 and 1 to the 3/2 is just 1. So this will be 27 minus 1, that's 26. So 52 over 9. I don't think I can reduce that. That's number 18, number 19, and 20 later on here. Number 19, integral from 1 to 5 of dt over t minus 4 squared. Well, by the way, this is just the same to say integral from 1 to 5 of 1 over t minus 4 squared dt. Okay, it's multiplication. Okay, so this is how do I do this? I think I need to do substitution first. Yeah, so tu equals to t minus 4. Hold on. There's an issue here. It is hold on. If x is hold on. I think I cannot go too fast. At least at this point. Notice that it is not continuous. In fact, it jumps to infinity at 4, huh? Okay, 1 over t minus 4 squared is limit of t goes to 4 is equal to infinity. So 1 over t minus 4 squared is not continuous. It's infinite discontinuity at t equals to 4, right? Okay, so the integral from 1 to 5 dt over t minus 4 squared does not exist. Okay. Oh, that's surprising for me too. Thomas, you didn't check those things before. Well, because we have all polynomials, as I remember, right? Except number 15, but it is undefined at u. The interval does not include not defined at u equals to 0, but the interval does not include 0. So we are fine there, and the rest are actually well defined everywhere. Only number 19 is not. Okay, number 20. Number 20, sorry, I kind of like squeezed that in. Integral from 0 to 1 of sine 3 pi t dt. I think this is an easy substitution. 3 pi t as my u. Du equals to 3 pi dt. At 0, that's 0. At 1, that's 3 pi. Okay, so now our integration now becomes integral from 0 to 3 pi of sine u du over 3 pi. Okay, that is 1 over 3 pi. Sine at 3 pi, oh, that's multiple pi. That's 0 minus 0 then, huh? That's 0. Oh, hold on. No. I forgot to integrate that. I need to integrate that first. The integral is negative cosine. Negative cosine u from 0 to 3 pi. I almost make a mistake, huh? Okay, so that's 1 over 3 pi, 1 minus negative 1. So that's, oh, good thing I didn't. Good thing I said that. So 2 over 3 pi. Yeah, at cosine 3 pi is negative 1. With that negative, it becomes positive 1. Okay, and then negative cosine 0 is 1. Negative cosine 0 is negative 1. Okay, let's go on. We have a lot to do today. A lot of integration. I need you to be really strong on this though. And that's why I do all of them. Okay, number 21. Integral from 0 to 1 phi squared cosine phi cube d phi. So u equals to phi cube. Du is 3 phi squared d phi. At 0, that's 0. At 1, that's still 1. So this is integral from 0 to 1 cosine u du over 3, right? Because phi squared d phi is our d phi over du over 3. Okay, so this will be 1/3 sine u from 0 to 1. That will be 1/3 sine 1 minus sine 0, which is 0, right? That's for number 21. Number 22. Integral from negative 1 to 1 of sine x over 1 plus x squared dx. I don't think we can integrate this for now, but you notice that, note that the integrand sine, let me call that fx equals to sine x over 1 plus x squared is an odd function. Of course, you need to show why though, why you call that odd functions. You cannot just claim without evidence, right? Okay, proof f negative x equals to, so when I go over this review, I also show you how you need to show your work. Okay, so 1 plus negative x squared, that's equals to negative sine x on the top. Yeah, sine negative x is negative sine x. At the bottom, we get the same denominator, but this is actually negative fx. Okay, so fx is odd. Okay, and then therefore, since the interval of integrations is in form of negative a to a, basically they are opposites, then integral -1 to 1 of an odd function as long as they are continuous in that interval though. Okay, equals to 0. Okay, that's number 22. Number 23. Number 23, integral from -pi/4 to pi/4 tangent to the fourth t to the fourth tangent t/2 plus cosine t dt. This is too hard to integrate. I don't think so. So, but because the limits of integrations, the interval of integration is an opposite constant, then let's suspect that this is even, or I think it's doable if it is odd, right? Okay, so let's see. Note, let's take a look on ft equals to t to the fourth, which is an even function, tangent t, which is odd. So on the top is odd, right? Over 2 plus cosine is an even function. So odd divided by even, it becomes odd function. Okay, and then you show that f negative t gada bum equals to negative ft. You show it. Okay, basically very similar to what I did at the on the left hand side, and then you conclude so ft is odd, and since the interval of integration is in form of negative a to a, then that integral negative pi/4 to pi/4 of t to the fourth tangent t over 2 plus cosine t dt must be 0. Okay, now again we need to make sure that the denominator does not get to 0. As for number 23, number 24, number 24 is a indefinite integral. So indefinite integral, you need to get the constant at the end. Okay, integral x plus 2 over square root of x squared plus 4x dx. Dang, this is scary, but nah, not really. Why? Because think about which one you cannot do, like so hard to do. And maybe that's the one we need to substitute, right? So our u equals to x squared plus 4x. The u then is 2x plus 4 dx, which I can factor the 2, right? And notice that x plus 2 dx is actually what we have on the numerator. See, right? Okay, so this guy becomes integral du over 2 and then u to the power of negative 1/2. Okay, which is 1/2 times 2 u to the power of 1/2 plus constant, of course, which is u to the 1/2 is square root of x squared plus 4x plus constant. Okay, that's for number 24. Let's see the next one, number 25. Integral, oh, this one is hard. Integral of sine pi t cosine pi t dt. I can do this problem with 3 different ways. But yeah, I can do it with 3 different ways. First one is the first method. Let's see. What is the issue actually? See, if I use my u as sine t, my derivative is cosine. Is the cosine form. Okay, so the first method is I use u equals to sine pi t. The du will becomes cosine pi t times pi dt. Right? Notice that cosine pi t dt later on being absorbed. This is my du over pi. Okay, so this is equals to integral u du over pi. Is it right? That's 1 over pi u squared plus constant, which is 1 over pi sine squared pi t plus constant. That's the first way. Now, if you think about it, the second way, which I can say just similar idea with the first one, but the u we use is cosine pi t. So cosine pi t times sine pi t. I rewrite the order of multiplication. Okay. And then I say, oh, let's let u be cosine pi t instead. And du will be negative sine pi t times pi times dt, right? So this becomes integral u times du over negative pi, which will give us negative 1 over pi u squared plus constant. That's negative 1 over pi cosine squared pi t plus constant. Now, at this point, you may wonder, but Thomas, they look very, very different. That's right, they look very different. But with the constant, they are actually the same. With the constant, they are actually the same. Let me call this C1 and this is C2 and show that they are actually the same. Think about this. 1 over pi sine squared pi t plus constant 1, we can rewrite this as 1 minus cosine squared. Right? So this is 1 over pi minus 1 over pi cosine squared pi t plus C1. Now, I hope now you can see that this is our C2. Right? So no, they look different, but they will be very different if without constant. If you write them without constant. Okay, but we have constants, then they are actually equivalent. Another way to say this, like when you graph this function here, and you graph this function here, the graph will be exactly the same, except that they differ by constant, by some constant. Okay, let me erase the highlight. I think I start catching a cold. My son already got it, already recovered. My daughter then get it, she recovered, and then my wife got it, and she already recovered. I think it's my turn right now. But at least my turn happens after them, not before them. Otherwise, I feel so bad. Now, the third method happens to be something if you don't know, it will be very difficult for you. But if you happen to know it, that will be really nice. You'll notice that I can multiply the top and the bottom by 2, right? But on the top, you see that 2 cosine blah sine blah. You know what? The original question is called sine cosine. That's sine 2 blah, right? Okay, and then this is 1/2 times 1 over 2 pi integral of that's negative cosine 2 pi t. plus constant, of course. Okay, so that's 1 over 4 pi with negative cosine 2 pi t plus constant. Is it okay? But Thomas, no, it doesn't look like what we have above again. Let's take a look. Let's take a look. This is a double angle formula. We use double angle formula, right? This is 1 over 4 pi. I just try to show you that this guy is actually equivalent to one of those, okay? Which are already equal to each other anyway. I will use 2 cosine squared of pi t minus 1. Then I will get negative 1 over 1 over 2 pi. Huh? Why 2 pi? Why is it over 2 pi? Oh, that one I wonder. Cosine squared. Let me just do it first. Plus 1 over 4 pi plus constant. Oh, yeah, when I integrated, I forget the 1/2. Duh. When I integrated, I forget the 1/2. Now it works. Now it works. Okay, now this becomes another constant. Okay, so yes, they are the same anyway. They are the same. Yeah, good thing I do this third method. Otherwise, I don't realize I forgot the 1/2 at the top. Yeah. Okay, so you notice I did it with 3 different methods, right? Okay. They happens to be doable in 3 different methods. Usually we don't have that privilege though. Last one, number 26, integral sine x cosine of cosine x dx. Number 26, integral of sine x cosine of cosine x, cosine of cosine x dx. If my u is cosine x, my du is negative sine x dx, right? So this is my u, and this will be my negative du. Okay, so integral of cosine u negative du is equal to negative sine u plus constant, which is equal to negative sine of cosine u, cosine x I mean, plus constant. That's for number 26. Let's go on. Number 27 seems like it gets more complicated, huh? Okay, be patient. That's why we are here. That's why we learn, right? Nothing fun with easy stuff. Yeah, the suspense is with the harder part. 0 to, oh, this is a definite integral. So secant 2 theta tangent 2 theta d theta. Secant tangent, integral of secant tangent is what? Secant, huh? Okay, so I think the problem is with the 2 theta then. So let u equals to 2 theta, so du equals to 2d theta. Now u at 0 is 0. Oops, I tried to do it too fast. U at 0 is 0, and u at pi over 8 is pi over 4. Now that integrals becomes integral from 0 to pi over 4 secant u tangent u du, which is secant u from 0 to pi over 4. Now we don't use secant u plus constant because this is a definite integral. But at the same time, because we don't use constant, then we must use a limit, the interval of integration. Okay, which is secant pi over 4 minus secant 0. That's radical 2 minus 1. That's number 27. Number 28, integral from 0 to pi over 4. Oh, we have tangent in there. The derivative of tangent. Let me write it down first so that I see the details. 1 plus tangent t. I just say something very important. One way for you to see the details is to rewrite the question. Okay, let me call this my u. Let me call this my u. Notice that if my u equals to 1 plus tangent t, the derivative is secant square t. The limits of integration, for the limit change from at 0, that will be 1 plus tangent 0, that's 1. At pi over 4, 1 plus tangent pi over 4 is 2. Okay, so my integral now becomes integral from 1 to 2 of u cubed du, which is 1/4 u to the 4th from 1 to 2. That's 1/4, 2 to the 4th, 16 minus 1. That's 15 over 4. Okay? Yeah. Remember, if you apply limits or you'll apply substitution method to a definite integral, the u sub, convert the limit. I keep on saying it's a limit of integration because it is, okay? But when you say limit of integration, it refers to the interval actually. Okay, number 29. Integral x 1 minus x to the power of 2/3 dx. My u is 1 minus x, du is negative dx. So this integral becomes, oh, what is the x? X is 1 minus u, and then u to the power of 2/3 negative du, which is equals to negative integral u to the 2/3 minus u to the 5/3 du. This is negative of 3 over 5 u to the 5/3 minus 3 over 8 u to the 8/3 plus constant. Then we're supposed to substitute 1 minus u by 1 minus x, right? But notice that we have common factor there. We have common factor there. Okay. In class, I factor the coefficient, the fractional coefficients also. Let me just do that also now here. So we have common factor 3 over 40 u to the 5/3, right? Okay, so the first term, there will be 8 minus the second term, that will be 5 u. Okay, so that's negative 3 over 40, 1 minus x to the 5/3, 8 minus 5 times 1 minus x. So this should be what you have. That will be 3 plus x plus constant. Okay, that's for number 29. Let's see, number 30, integral of secant square tangent cube. We actually will see this again in Calc 2 though, but we can do that already right now. The issue is which one we use. Do we substitute the secant or do we substitute the tangent? But the way we see this is the derivative of tangent is secant squared, which we already have there, right? So I think that's our u should be u equals to tangent theta, such that our du to be secant squared theta, d theta, right? So this is integral of u cubed du, which is 1/4 u to the 4th plus constant. Once you finish the integration of an indefinite integral, don't forget to use plus constant right away. Okay, this is equal to 1/4 tangent to the 4th theta plus constant. That's number 30. Number 31. Oh, this seems to be a harder one. Because we have absolute value. Number 31, integral from 0 to what? 3 of absolute x squared minus 4 dx. We did this in class, right? Yeah, so we need to see when is x squared minus, let's do the sign graph for x squared minus 4. Sign graph for x squared minus 4. We know the critical numbers are -2 and 2. Okay, it will be positive on the right hand side, negative here, positive here. But we just need from 0 to 3. From 0 to 3. Okay, from there we see that absolute of x, yeah, so absolute of x squared minus 2, minus 4 I mean, is positive in our interval. Okay, in our interval is positive on 2 to 3. Okay, and negative, so I put another negative to make it positive on 0 to 2. Okay, now with that mindset, then we break this integral up, becomes integral from 0 to 2 of negative x squared minus 4 dx plus integral from 2 to 3 of x squared minus 4 dx. Okay, I try to squeeze that. Now this is integral, the integral of this is -1/3 x cubed plus 4x from 0 to 2 plus 1/3 x cubed minus 4x from 2 to 3. And then from there we just plug in numbers. Okay, so that's -8/3 plus 8 minus 0 plus 9 minus 12 minus, when I plug in 2, that's -8/3 minus 8. What is that? This is -3 plus 16, that's 13 minus 16/3. Sorry, -3 plus 16, that's 13. Right, and then minus twice 18/3, so this is 39 minus 16/3, that will be 23/3. That's 31. Let's see what is 32. Integral from 0 to 4 or square root of. Integral number 32. Integral from 0 to 4 of absolute of square root of x minus 1 dx. Now the sign graph on square root of x minus 1, I think the critical is at 1, right? When x greater than 1 is positive, when x is less than 1 is negative, but the boundary is still at 0. That's the domain of the function. We will observe that only up to 4. Okay, so absolute of square root of x minus 1 is square root of x minus 1 for between 1 to 4. Okay, and then 1 minus square root of x between 0 to 1. Okay, if you can imagine what happened in between here, you can just go directly. It's like for example, you notice that the cutoff is at 2, right? Less than 2 is negative, so between 0 to 2 you take the opposite of that expression, and then greater than 2 you take it as is. Now, so here we know that between 0 and 1 it will be negative, so from 0 to 1 I take the opposite of that square root of x minus 1. And between 1 to 4, because the absolute of that is already positive there, we just take it as is. Okay? And from there you integrate as usual. Let me just leave it like that. Okay, you can integrate it yourself, but I want you to actually meditate on how do we break it up, and when we attach the negative, and when we don't. Okay. Next one, number 33. Number 33. Find that integral. Okay, my u is 1 plus sine x. So my du will be negative cosine x dx. The integral now becomes integral negative du over square root of u. Oh, that's integral negative integral u to the negative 1/2. That will be negative 2 u to the power of 1/2 plus constant. Is it right? Which is negative 2 square root of 1 plus sine x plus constant. While number 34, similarly, oh no, this is not so similar. Our u will be x squared plus 1. Du is 2x dx. I need to rewrite that integral first. So I will rewrite that as integral of x squared times 2x over square root of x squared plus 1 dx, which is integral of u minus 1, that's for the x squared, okay, over square root of u du, which is integral u to the 1/2 minus u to the negative 1/2 du. Okay, I think that one is easy. 2u to the power of 1/2 minus no, 2/3 3/2. And then this is the 2u to the power of 1/2 plus constant. Oh, this one I think we need to, later on we need to simplify more. So let me take more space. I will factor the 2/3 u to the power of 1/2. So I get u minus 3 plus constant. And by what is my u again? That's a square root of x squared plus 1. And this will be times x squared plus 1 minus 3. Let me write it better way. 2 over 3 x squared minus 2 square root of x squared plus 1 plus constant. When you do the derivative here, I believe you need to do product rules, right? Okay, when you do product rules, this thing cancel that thing, and we will get this again if we do the derivative. You want to try? Let's try. This is one way to check if we did it right though. Okay, so let me move the 2/3 out, and then inside I will get 2x square root of x squared plus 1 plus x squared minus 2 times 1/2 x squared plus 1 to the power of negative 1/2 times 2x, right? The product rule. Okay, now then I have common factor square root of x squared plus 1. I also have common factor x, right? On the first term, I take the x out. I have 2 times x squared plus 1 plus I take the x out and this guy out, so I have x squared minus 2. Okay, so I have 2 over 3x over square root of x squared plus 1. Inside 2x squared minus x squared, that's just x squared. 2 minus 2 is that. So this will be, why I have x? Oh, I have 3x here. Yeah, so and then the 3 cancels. Where's the 2 from? No, I don't have 2. I have x cubed. Am I missing something? 2x squared. Yeah, I end up with 2x cubed over square root of x squared plus 1. Where's the 2 coming from? Let's see. Let me check. I don't think I make a mistake. I don't think I make a mistake. So this is my du. This is u minus 1. That one is correct. I'm checking my work. I'm still checking my work. Yeah, I have extra 2. Where did that extra 2 come from? I find my mistake. I happen to write that 2 there, which is not originally, which is not original. But let me just divide it by 2 then, okay? So this is 1/2, 1/2, 1/2. Yeah, why? Good thing I checked that. No, otherwise, I didn't even realize I happened to write that too, just to fit this picture here. So, yeah, supposed to be just like this now. Okay, so when I do the derivative, when I do the checking, it's supposed to be this, 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 and without that square. Then I get the same thing. Okay. Good thing I checked my work. Otherwise, I didn't realize I make that silly mistakes. Maybe because I did it too fast too, though. Okay, that's for number 34. Let's go on. Number 37. Find the area under the graph. Find the area. We actually don't need to graph this though. But from 0 to 4, I sketched that just to get the idea. X squared plus 5, so it's fully above the x-axis, right? So the area, number 37. The area equals to integral from 0 to 4 of x squared plus 5 dx. Okay, I think you can integrate yourself. Number 38. find the area under the graph of y equals to sine x. Sine x looks like this. And x-axis between 0 to pi over 2. We know the answer, the area is 1. But the setup integral area equals to integral from 0 to pi over 2 of sine x dx. Yeah, we know that is equal to 1. We see that so often that I'll expect you to memorize that though. Okay? Regions ABC bounded by the graph and the x-axis have area 3. This is area is 3 and area 2, -2 to be more precise because it's below, and this is 1. So part A, what is the integral from 1 to 5? This is 1, 2, 3, 4, 5. That's 3 minus 2 plus 1, which is 2. How about 1 to 5 in absolute value? That will be 3 plus 2 plus 1. Yeah, because when it's absolute, you basically flip that upside down, right? So the area becomes positive area, and then you add them. Okay? That's equals to 6. How about integral from 1 to 4? Number 40. 1 to 4 is 3 minus 2. And then 3 to 5. That will be -2 plus 1. Okay, that's equals to 0. This is 2 times integral 1 to 3 of fx dx plus 6 times integral 3 to 5 of fx dx. Now, integral from 1 up to 3 is 3. From 3 to 5 is -1, right? -2 plus 1, that's -1. That's also 0, huh? Oh, okay. Yeah, this question, as you see, it's more about your understanding how to read the graph and what that means, what those means. Number 41 to 46. Find the derivative of the function. Number 41. Oh, fundamental theorem of calculus, the first part, right? Fx equals to integral from 0 to x of t squared over 1 plus t cubed dt. You are not to integrate that even if you know by fundamental theorem of calculus 1, then the derivative of that function x respect to x will be, you basically replace the t by x in the integrand. Oops, should be x here. Okay, just like that. Now, if you want a further explanation the way I explained it in class, then you can see this actually, if this integrand of this, if the integrand of that is g, then this will be gx minus g0. Okay? Now, when you do the derivative of that, this becomes 0. Okay, but the derivative of gx is the function inside, right? It's the function inside. Okay, which is t squared over 1 plus t cubed, but we replace the variable by x. Okay, that's for number 41. Number 42. If you have fx equals to integral from x to 1 of square root of 1 plus t plus sine t dt. There are two ways to look at these questions. Let me do it long way and then give you the shortcut. Okay, notice that because the x is at the bottom, I will first reverse the interval of integration, becomes like this. And then when we apply fundamental theorem of calculus, the first part, we will get negative square root of x squared plus sine x. But I hope you see that if the variable x is at the bottom, you have that extra negative. If the variable x is at the top of that interval of integrations, you keep as is. Okay, now number 43. What happens if it's not an x in the interval of integration but a function of x? Then we replace the t by that function when you do the derivative, right? You replace the t by that function. So let me use notation g prime. G prime x will be, we replace the t by that function times the derivative of that function. Okay? Which will be cosine x to the 8 times 4x cubed. Okay, number 44. Very similar idea. If gx equals to integral from a constant to a function of x, 1 minus t squared over 1 plus t to the 4th dt, then the g prime x will be 1 minus sine squared x over 1 plus sine to the 4th x times the derivative of sine x. Okay, which will be cosine x. But I have another, I have cosine square x from here. Let me just put it as cosine cube x over 1 plus sine to the 4th x. Number 45, what happens if we have functions on the top and the bottom of interval of integrations? Number 45. You can think of that you split, like find a number in between that you can split them. But I think you can just go ahead with this. Y equals to square root of integral from square root of x to x of cosine theta over theta d theta. The y prime will be on the top. You replace, right? You get cosine x over x minus cosine square root of x over square root of x multiplied by the square root, the derivative of square root of x. Just for the second term, this becomes cosine x over x minus cosine square root of x over square root of x times 1 over 2 square root of x. Simplify will give us cosine. Actually, I have 2 cosine x minus cosine square root of x. I do the LCD, by the way, over 2x. Okay, that's for number 45. And last one, number 46 for this part here. Y equals to integral from 2x to 3x plus 1 of sine t to the 4th. This is not integrable, by the way, at least for your level. Okay, but we can do the derivative of this integral. Okay, so the derivative will be replace the t by the upper limit of the integral of integration multiplied by the derivative of that function. Let me write it this way, minus sine of 2x to the 4th times the derivative of 2x respect to x. Okay, so that will be 3 sine 3x plus 1 to the 4th minus 2 sine 16x to the fourth. Because I can simplify that easily, then I just do simplify that. That's for number 46. Number 47, use property 8 of integrals to estimate the value of the integrations. I don't know what is property 8, but I assume that it has something to do with the maximum minimum. I assume it has something to do with maximum minimum. So let's see number 47. Okay, square root of x squared plus 3 on that interval 1 to 3, you see that it's increasing, huh? In the function is here. I mean, x squared is an increasing function there, right? So we can say this square root of x squared plus 3 will be less than equals to square root of 3 squared plus 3. That's the upper bound, and this is the lower bound, right? In other words, the lower bound is 2. The minimum value of x squared plus 3 in that interval is 2, and the maximum value is square root of 12, which is 2 square root of 3. So the integral from 1 to 3 of square root of x squared plus 3 dx must be between 2 times the length of the interval, and that's the lower bound. Because 2 is the lower bound of the function, then 2 times 2, which is 4, is the lower bound of the integrals, multiplied by the length of the interval, right? And this is 3 times 3 minus 1. So it is between 4 and 4 radical 3. I think that's what property 8 says. I don't remember precisely though. How about number 48? Now, x squared or x cubed plus 2 is on that interval 2 to 4. Again, it's an increasing function, so x squared plus 2 must be between 2 cubed plus 2 and 4 cubed plus 2. Is it right? Now, then when I apply the square root is also a one-to-one function, so the inequality being preserved. However, when I do the no square root. What am I doing? Why do I do square root? But when I do the reciprocal, the inequality is being resolved. Note that this is positive, right? Okay, so 1 over x cubed plus 2 must be less than equals to 8 plus 2. That's 1 over 10. Must be greater equals to 64, 1 over 66. Okay, so integral from 2 to 4 of dx over x cubed plus 2 must be bounded above by 1 over 10 times the length of the interval, bounded below by 1 over 66 times the length of the interval. Okay, so that integral must be, if x is, which I know it's x is, must be at most 1/5, but at least 1 over 33. Okay, it will not be more than 1, but still positive. Now we know it's positive because this function is positive in that interval, right? But what is the upper bound? What is the upper bound? Lower bound. So even though we cannot compute the exact value, we can more or less tell what is the value of the interval where the value of that integral located. Okay, number 49, verify this property. Well, okay, x squared cosine x is positive, okay, but maybe I put it this way. Let me put it this way. Cosine x is between 0 to 1 for x between 0 to 1, right? In fact, cosine x is always less than 1. Agree? When I multiply by x squared, then it will be less than equals to x squared. Is that right? When I integrate from 0 to 1 of x squared cosine x dx, then it must be bounded above by integral from 0 to 1 of x squared dx. Is that right? While this guy is actually 1/3. When you integrate that x squared from 0 to 1, that will be 1/3. So that's how we prove it. Now likewise, we know sine x is between, actually, the lower bound, no, I don't need the lower bound, huh? Yeah, the upper bound is 1, right? Dividing by x is actually a hard one. Yeah, x is also between, the thing is the x here is between, you know what? So sine x over x must be less than 1 over x. Is that right? Now integral from pi over 4 to pi over 2 of sine x over x dx. Actually, that's not how. I will not get what I want here. I will not get what I want here. Seems, well, because I need this guy. I need this guy. Ah, you know what? Yeah. All right, now I get it. Now I get it. Notice that for x between pi over 4 to pi over 2, oh, why this question turns out to be more difficult than what I thought. Yeah, let's compute that first then. Let's compute that first. What happened with okay, so in that interval we know that sine x is sine is increasing in that interval, right? So it's the lower bound is sine pi over 4, the upper bound is sine pi over 2, right? So it is bounded below by radical 2 over 2 and bounded above by 1. So if I divide by x, what happened? The thing is the x is between those two numbers though. Or should I? Let's do 1 over x first then. Let's do 1 over x first. So 1 over x is 1 over x is what is the minimum? So it will be, you hardly see me getting stuck, huh? So 1 over x will be between 2 over pi and 4 over pi. Yeah, this is the purpose. That's the purpose. So multiply by sine x. This will be 4 sine x over pi. Then that's the lower bound. Okay. Oh, nah, I think I get it. I think I get it. So, but 4 over pi is, oh, this is more than, huh? This is more than 1. This is more than 1. This is more than 1. I want to say that if I integrate this later on, right? From pi over 4 to pi over 2. This will be negative cosine x. Oh, I forgot the 4 over pi of negative cosine x from pi over 4 to pi over 2. Then I get 4 over pi of cosine pi over, that's radical 2 over 2. It's, I think like I kind of like overkill it. I'm still thinking. I am still thinking. I am still thinking. You know what? Let me take a little break. I pause the recording first. You know what? Thinking about it, this question may not be that easy. What I need to do is to find, let's call this a function fx. And I would like to find what is the maximum value on that interval. Okay, so it's not something I can just approximate like number 49. Because sine x between pi over 4 to pi over 2 is increasing. It is increasing. That's the sine x, right? But x also increasing. That's the thing. Both of the slope are increasing. So we don't really know which one go increase faster at what point. So for that, let's do the derivative. Okay, the f prime x will be, this is x squared here, cosine x times x minus sine x times derivative of x. Okay, so that's what we have. And if I set this equals to 0, I will get x cosine x equals to sine x. So x equals to tangent x. Seems like it's no way for me to solve this though. Yeah, seems like there's no way for me to solve this. Where does tangent x intersect with x? That one I don't really know. Yeah, that one I don't really know. I need to use Newton's method to solve that though. I need to use Newton's method to solve that. Okay, but I think I can do some approximation. Let's try. Tangent pi over 4. Pi over 4 is less than 1. Tangent pi over 4 is 1. At pi over 4. If we increase a little bit at pi over 3, that's less than 1, but tangent pi over 3 is radical 3. So and how about the sine graph? Let's say we have a pi over some number. Okay, pi over some number. Will this be positive when that? I think this will be positive here, it will be negative here. Yeah, so that's the local maximum. This number is the local maximum. I don't know what number is that though. I don't know what number is that. I can use pi over 3. I think I can use pi over 3. No, pi over 3 already going down, huh? Pi over 3 already going down. So, yeah, but the number for sure is between pi over 3 and pi over 4. Okay, must be between those two numbers. Honestly, I cannot solve this problem yet. Yeah, I cannot solve this problem. But let's say that number is pi over 3, then this value here will be less than equals to something with pi over 3. Whatever number is this, okay? Pi over whatever number. I need to find it out. But then when we integrate from pi over 4 to pi over 2, of sine x over x dx, this will be pi over whatever that is times the difference, the length of the interval, which is pi over 4. Okay, so that's I think that's the number I can use right now. Pi squared over 4, whatever that is. I'm sorry, I cannot give you the precise answer here. Yeah, I would like to cheat and look at the solution manual and give you the answer, but I'm sorry, that's just not what I can think of right now. Okay. Yeah. If this were pi over 3 instead of pi over 4, then it's okay. Do you know why? Yeah, if that's pi over 3 and if this were, let me change the question a little bit then. Let me change the question a little bit. If the integral is from pi over 3 to pi over 2, and I can say that on that interval, it's decreasing already. The function is decreasing already. And if the function is already decreasing, then I can use the value on the maximum value must happen at pi over 3. You see? Okay. So if this were the question, okay, so sine x over x is less than equals to sine pi over 3, which is radical 3 over 2 over pi over 3, which is what? Radical 3 over pi 3, like this, right? Okay, multiplied by the length of the interval, which is pi over 6. You see what I mean? So radical 3 over 4. But because it starts from pi over 4, where the value here is more than 1, I can't really do it that way. I can't really do it that way. Unless I split this integral into integral from pi over 4 to pi over blah, the one that make them equal, plus integral from pi over blah to pi over 2. You know. But again, I'm sorry. I cannot in my conscience answer it this way. Yeah. Let me just say I give up. I give up to achieve this what they want. Okay, I give up to achieve what they want. But can I find other limits beside that? I think I can. Yeah, I think I can. You know, but let me just not doing that. So let me say I can give or I can prove the inequality. Prove or verify this inequality in simple way. The upper bound of radical 2 over 2 for your level. Yeah, for your level. Unless I can do it another way. Act like for example, sine x is less than 1 in that interval. So when we divide by x, it's between, that guy is, then this will be less than equals to pi over 2. I mean 2 over pi, 4 over pi. Okay, and then integral from pi over 4 to pi over 2 of sine x over x dx. This is bounded above by 4 over pi times the length of the interval, which is pi over 4, which is 1. Okay, but 1 still greater than this. 1 is still greater than that. Like, I can't really say it that way. I cannot achieve what I want, you know. But the best way, like what I said earlier, if we can find where is this maximum, it's maximum when tangent x equals to x. You know what? Let me go on further. I know this is way outside of my time already, but let me go to here. Let me share with you if I do graphing calculator. So I basically try to find where they intersect. Okay, x equals to tangent x. No, I'm sorry. Y equals to x and y equals to y equals to x minus tangent x, and we try to find the x-intercepts. But no, huh? Am I making a mistake or something? This is pi over 2. And pi over 2 equals to infinity. Negative infinity and infinity. It's not 0. So there's no 0 between that, huh? You know what? Let's just see what the graph look like then. Sine x over x. Between pi over 4 to pi over 2. Between pi over 4, it's around 1.5. Pi over is like... because we use pi, let me put pi here. Insert. Where's that keypad? I want to insert pi here. Yeah, pi. So let me screenshot this. And put it in here. I think this will give us a much better estimation. See, you see, I don't give up. Yeah. Let me put what the graph look like here. So this is the graph of sine x over x. Pi over 4 is approximately 3/4, approximately here. And pi over 2 is slightly more than this. So yes, the function is maximum at that number, pi over 4, right? 3 point, yeah, so the function is maximum here, the minimum here, at pi over 4. But it reached the minimum here. Okay, so it is increasing somewhere there, right? Yeah. So using this graph, then I can say something. Okay, then sine x over x, even in absolute sign, let's go back to the graph. If I put absolute, That's what it looks like. Even under absolute sign. Where am I? I'm still here. Okay, I'm working on this. Yeah, so even under absolute sign is maximum at x equals to pi over 4. Now I have some justification. Yeah, now I have some justification. Yeah, so it seems like my approach earlier to do the first derivative is correct. You know, it's just like yeah, that's the minimum, huh? Okay, so sine x over x is maximum at that, and the value of the maximum is less than equals to sine pi over 4, which is radical 2 over 2 over pi over 4. So that's 2 radical 2. Okay, now in that integral from pi over 4 to pi over 2 of sine x over x is less than equals to 2 radical 2 times the length of the interval. Oh, I'm missing the pi, I think, over pi. Okay, then we get, yes, that's what we get, yeah, radical 2 over 2. So then we prove it. But to say that this absolute of sine x over x is maximum there, we need to do the first derivative. Okay, and check the endpoints, huh? We need to check the endpoints. Let's do it without graphing calculator. At least now we already see that that's the case. I don't want to let this go. I still cannot let this go. So let fx equals to sine x over x, then f prime x is x cosine x minus sine x over x squared. Now, we have earlier this is equals to 0 when tangent x equals to x, is it right? Which we found the root is between pi over 3 and pi over 4. Is it right? Okay, so call that c. This is pi over 4. We have c here. We have pi over 2 here. Okay, so that's the slope is 0. And then now let's plug in number. Suppose I plug in number at pi over 4. At pi over 4, pi over 4 times cosine pi over 4 is radical 2 over 2 minus radical 2 over 2. This is radical 2 over 2 pi over 4, which is less than 1 minus 1. So this is negative. And later on this becomes positive then, right? Okay, so it is decreasing here, increasing here. This is the local minimum. Okay, that's the local minimum. We don't know what's that C, but the value here will be, yeah, the value here will be, yeah, pi radical 2 over 2 over pi over 4, while this one here, that will be 1 over pi over 2. While the value here, do we have x-intercept in between? No, we don't. Yeah. We have x-intercept for the f prime, right? So it is decreasing here. And yeah, it's decreasing. So the maximum is still this number, huh? What I'm afraid is it goes down to negative, but apparently it will not go down to negative. So the value there is, this is 2 over pi. The value is decreasing, and then later on it increases a little bit, right? But it's still highest here. Okay. So what's that? Extreme value theorem. Like if you have a closed interval, then the extreme value happens at the critical number or the endpoints. Now we find that it is at the endpoints. So that's how we then come up with this. Now we get it. Okay. Whew. You know, it's not strictly decreasing though. This function is not strictly decreasing between pi over 4 and pi over 2. That's the problem. Okay. It is increasing a bit, right? So I need to show that even when after it increases, it does not increase more than the value at the left hand side. Okay. This is clearly positive on pi over 2, pi over 4 to pi over 2. Okay, so then we continue with that. Now we get the inequality. Oh, this is the question I spent the most time, huh? My bad, I'm sorry. Number 52. A particle moves along the line with this velocity where v is measured in meters per second. Find the displacement. Part A. I will just do it fast then. I spent too much time already. Integral from 0 to 5 of that velocity. Okay, you can compute it yourself. Part B, how about the distance traveled? Then it will be integral from 0 to 5 of the absolute value. Okay, now notice that the t squared minus t graphs looks like this. When we do the absolute value, then between 0 to 1, you need to flip that, right? So this is integral from 0 to 1. We flip that. Then between 1 to 5, we don't need to flip anymore. Okay, you compute that from there. Number 57, f is continuous. F integral from 0 to 2 f fx dx equals to 6. Now evaluate this. Oh, u substitution first. U equals to 2 sine theta. So du is 2 cosine theta d theta. Okay, and u at 0 is 0. U at pi over 2 is 2. Therefore, this integral now becomes integral from 0 to 2 of fu du over 2. Okay, because this is our du over 2. Okay, this is 1/2 integral from 0 to 2 of fu du. But fu integral from 0 to 2 fu du equals to 6. That's equals to 6. So this is 1/2 times 6. That's equals to 3. That's 57, 59. If f is a continuous function such that we have this for all x, find an explicit formula for fx. Dang. You know what? We do implicit differentiation. Implicit differentiation with respect to x. If I do respect to x here, I get fx. When I do implicit differentiation here, I get sine x, the product rule, plus x cosine x, plus implicit differentiation here, it will be fx over 1 plus x squared. Okay, so I move to the left, fx minus fx times 1 over 1 plus x squared equals to sine x plus x cosine x. Is it right? So fx times 1 minus that. But I hope you can see this is basically fx times x squared over 1 plus x squared. Is it right? Equals to sine x plus x cosine x. Therefore, our fx must be this expression here times the reciprocal of that, 1 plus x squared over x squared. Okay? Now we get the explicit function of x. Find a function f and a value of constant a such that we have this guy here. Oh, implicit differentiation again. Implicit differentiation with respect to x. So when I do the derivative here, that will be 2 times fx equals to 2 times cosine x. So fx equals to cosine x. Okay, now, so let's try that. So coming back here. So integral 2 times integral from a to x of cosine x dx equals to 2 sine x minus 1. On the left hand side, so basically I need to get 2 sine x minus 1. So but when I integrate the left hand side, I will get 2 times t, not x. That's 2 times sine t from a to x equals to 2 sine x minus 1. This is 2 times sine x minus sine a equals to 2 sine x minus 1. Which means if I distribute and cancel, 2 sine x cancels. 2 sine a equals to negative 1 then. Negative 2 sine a. So sine a equals to 1/2, right? So a should be pi over 6 then. Or any functions that give you pi over 6. That give you sine a equals to 1/2. Maybe I write it pi over 6 plus 2 pi k, or 5 pi over 6 plus 2 pi k also okay. Okay, so that's why they use a value of constant a instead of the value. Okay, because there are multiple possible value for that constant a. Number 61. When will I end? That's so many questions, Thomas. If f prime x is continuous on AB, show that we have this function. You know what? Let's use this. So let u equals to fx, then du equals to f prime x dx. Okay, so this is equals to 2 times integral from fa to fb of u du, is it right? Which is 2 times 1/2 u squared from fa to fb. Is it right? Okay, which is u squared from fa to fb. Yeah, but that is fb squared minus fa squared. I just wonder why they don't write it this way though. The following is actually a common way to write that expression. Okay, that's for number 61. How about number 62? No, actually, I need to say that this question is, of course, the one I like, right? This one makes sense. All the integral, of course. So the one I circles are the one that I have interest in asking in my tests. Okay, so 33 and 34 also. And I think I've already mentioned everything from 11 to 32. Okay. And the one before this is actually, it's not that I will not ask them, but it's too easy. The main focus of this section is really integration, fundamental theorem of calculus, and substitution method. Okay. Will I ask question like number 62? I don't know. But let's think about this. What is this like? So we say let ft be be the indefinite integral of 1 plus square root of 1 plus t cubed dt. Okay, so that integral from 2 to 2 plus h of these is equal to f of 2 plus h minus f at 2, right? Now, when we put 1 over h, we get this situation, right? But then if you say the limit h goes to 0 of f2 plus h minus f2 over h, this is by definition is the derivative of that function at 2, right? But the derivative of that function f prime t is just the integrand, right? Okay. Maybe I just to clarify. So this is under the condition of limit. Okay, and that's for number 62. And then number 63, if f is continuous, prove this. I will do substitution. So integral from 0 to 1 of f1 minus x dx, if I do substitution, u equals to 1 minus x, du is negative dx, u at 0 is 1, u at 1 is 0. So this will be integral from 1 to 0 fu negative du. That's integral from 0 to 1 to absorb the negative. But this guy is just simply the play of variables. If you don't like fu du, we can replace that with fx dx. Right? Okay, number 64, this is last one. Evaluate this integral here. What the heck? Okay, so this is limit n goes to infinity of, this is the summation of I over n to the ninth, where the I start from 1 to n of 1 over n. Okay, well, this tell us that the length of the interval is 1. So b minus a equals to 1. Okay, and this tell us the fx, the f I over n equals to I over n to the ninth. So our fx is x to the ninth. Okay, but when I equals to n, it becomes 1. When I equals to n, we get I over n equals to 1. So that's the endpoints, So this is equals to integral, the endpoint is 1, of x to the 9 dx. Okay, now the length of interval is 1. If b equals to 1, then the a must be 0. Oh, okay, this is 1 over 10. Okay then, that's for this chapter 4 review. Let me stop the recording.